No, you're finding it too.
Yeah, screen share.
Okay.
And just go. Turn your mics on. Turn everything on.
I think they muted themselves, but I can't change it.
So your connection's better now.
Yeah, it has gotten better for sure.
Let me just try something. Our mic's on.
Hi, can you hear us?
There we go.
Hey, hi you guys.
Yeah, we can hear you.
Okay, perfect. Excellent.
Okay, great. So we have Paul here from the Canadian Museum of Nature, and he's going to talk your questions, and then when he's ready to take a question, he'll just, I'm ready for a question. So here he is.
Okay, perfect.
Paul.
Hey, Paul, nice to see you.
Hi, it's nice to see you as well.
Cool.
So, welcome to the C3. We're basically in the middle of the Arctic islands, if you can sort of imagine all the islands, and then down below is where you are, and then we're about halfway up the islands, and currently it's perfect weather and with no wind, so that's very, very nice. So, I've been asked to talk about contaminants in the Arctic, and this is an interesting, but it's going to be a rather problematic talk, given the fact that it's not going to be a two-way conversation, but I'm going to give it a try. So what we need to do, the first question is define what is actually a contaminant. And so that's the struggle with. And so I'm going to ask you, and then I'm going to try and get you to respond back about what you think contaminants. My question to you, what are contaminants?
Hello. Hello. Hi. Contaminants. What are contaminants, you guys? Do you guys know what that is? What that means? That's an interesting word. Have you heard of that word before? Contaminants? That means no, eh? It means pollutants. Yeah, it causes pollution. Oh, that was your first question, Paul?
Pollution? Yeah, so the answer came back that the contaminants are pollution. Okay, so if contaminants are pollution, who is creating the pollution, or where does the pollution come from?
You.
Hey, guys. From you? Who said that? Because you're right. You're right. It comes from us. It comes from you. It comes from me. And so we need to understand a little bit about what pollution actually is, or what contaminants are, before we can start talking about contaminants in the Arctic. So I'd like you to give me some examples of some contaminants that you can think of. So just yell them out.
Sulfur.
Sulfur?
A building.
Sorry, what was that?
Smoking.
Smell? Well, that's an interesting one. Smoking, that's true. That's a good one, smoking.
Oil.
What about, can you think of any metals that might be contaminants?
We said oil here.
Metals.
Mercury.
Mercury.
We did nature.
Perfect. Perfect. So mercury is a good example of a metal contaminant. Other examples are things like copper, lead, zinc. There's so many different kinds of metal contaminants. So my next question is, what can you think of any other kinds of contaminants? And I'll give you a clue. They're man-made. So we make these chemicals. Can you think of any examples?
Plastic.
Yes, please, go ahead. Plastic's a good one. Yep, that's definitely a good one. What else?
Tomatoes. Chain smoke.
Tomatoes? So I think what we're talking about here is things that we make would be things like or what we call organic contaminants, and these are things we use in the food industry. We also have contaminants like radiation. We make radiation, or there's radiation contaminants, so that's a problem. Also contaminants, believe it or not, in herbicides and pesticides, the chemicals we use in, on the crops down home. So there's all kinds of different examples of these contaminants. And guess what? As you said, we make the contaminants. We either make the contaminants or we at least manipulate the contaminants to help us grow our food, to make plastic, as you said, or to make other products. So we've defined what contaminants are. So the question now is, where do the contaminants come from to get into the Arctic? So how do the contaminants get into the Arctic? So again, just yell them out.
The ocean.
Perfect. Ocean. Good. Next.
In the air.
The rivers.
Air. Perfect. So there's ocean, there's air.
I find the lakes.
Okay. What about that we bring the chemicals up ourselves? So we actually bring them up by ship, or we fly them up. That's another way contaminants get into the Arctic. And there, believe it or not, there's another way contaminants get into the Arctic, or are in the Arctic. And that is the contaminants are already there. So if the contaminants are already there, then we have a scenario of accumulated contaminants. So my next question is the Arctic polluted? Are the contaminants in the Arctic a problem?
Maybe. Yes. Maybe. 50-50. Maybe. 50-50. Yeah.
50-50. I have a maybe, I have a 50-50, and a yes.
Maybe.
Any other,
Maybe.
any answers?
Potential.
Maybe.
Potential.
Surprisingly enough, the contaminants in the Arctic actually are not a problem right now. Okay. Moving. So watch us move.
Wait, just hang on.
Okay.
Can I see outside?
We're just going to take you outside right now.
Thank you. Yay. Better put my woolly jacket on. Yeah. Hi.
You're gonna unplug this. You're gonna run it out there and plug the cord that's out there waiting for you into this.
Yeah.
Count of three.
Okay.
1, 2.
Everyone, hang
go.
on one sec. We're just going to move outside because it's a beautiful day here. And we thought we would be better off outside. Hang on.
The lag is real.
We go. I'm going to hand the computer back to Paul here.
There we go.
Tour of where we are. For people.
Okay, so we're out on top of the bow of the ship. So you can see, there we go. That's the mainstay of the ship. So, okay. Okay. Can you see the, there we go. It's flipping back and forth, but there we go. So can you see the shoreline?
Yes.
Great. And notice one thing, we're in the ocean. What do you notice about the ocean? Look at the water.
Blue. It's dark. Darkish light.
Look at how smooth it is. Isn't that funny for the ocean to be so smooth?
Wait, what?
It's like no waves.
Exactly. Okay, sure.
I see.
Perfect. Okay, so we're back on the topic again. So again, we're talking. So this way. Again, we're talking about contaminants. So my question that I gave you was, how do the contaminants get up in the Arctic? And you responded by saying they get up into the Arctic by the air, water, and they get up into the Arctic by people. People bring them up into the Arctic. And finally, I suggested, oh wait, there's something else too, and that is that there contaminants are already in the Arctic. So can you tell me, or can you guess, what contaminants are already in the Arctic naturally? So give me an answer if you think.
Gas.
What kind of contaminants do you think are in the Arctic?
Gas. Gas.
Gas? Good. Very good. Excellent answer. Gas is a very, very good answer. What about, can you think of any metals? Do you think of any metals might be in the Arctic naturally?
Copper. What? Oh, yeah.
So for instance, just actually very close to here, there is a lead mine. So there's lead. There is arsenic in the ground. There is mercury in the ground. So there is all kinds of places where there's contaminants already in the water and in the Arctic. So my next question is, and we were talking to it, and that is it a problem? Is the contaminants in the Arctic a problem? And you basically responded, yes, maybe, whatever. The reality is, when you look at the overall landmass, that the contaminants in the Arctic are not that high. However, there is a problem in that although the contaminant levels are not high, they are in some places localized a problem, and that is at where people live. So every place where there's a community, there's contaminants. And also if there's any mining activity, and all around the mine sites there's contaminants. See about that is that those are very localized in the small areas. Contaminants. If somebody gave me the example of plastic, that there's plastics in the water, which is true. And so there are plastics coming in from the outside, i.e. in the waters in the ocean, the plastics are coming in. And one of the projects that we're doing here right now is we're trying to look at the plastics in the water. We call them microplastics, or microparticulates. And so one of the studies we're doing is we're grabbing a water sample and we're trying to see if we can find the contaminants. These contaminants, when they're present, are present in low numbers. But there's a bit of a problem, and that is, even though they're low numbers, if you remember when we talk about the food chain, and the fact that when the food chain goes from the small microscopic organisms that I study up to the very large polar bear, we have what's called an accumulation or bioaccumulation of the contaminant. So every time we get another organism in the food chain, we get an increase in the number of contaminants or amount of contaminants in the organism. And what's happening in the Arctic is that the small microscopic algae that I study have small amounts of contaminants, get up to the concentrations of the contaminants have increased to the point where it's a problem. And the other issue is that the people that live in the north, one of the mainstays or main things that they eat in their diet are mammals, polar bears, whales, seals. All these have basically elevated levels of contaminants. Now remember, I'd said before that overall contaminants are not a serious problem in the Arctic, but they are going to become a problem in the future. So one of the things we're trying to do right now is we're trying to make sure that we understand what the levels of the contaminants are now, so that in the future we will be able to understand how fast these contaminants are increasing and what kind of problems they are. So what I will do is I'll end my little talk before we get into the answers, and I'll tell you about two of the research projects that I work on. So the two contaminants that I work on are mercury. So both are metals, and both are metals are contaminants in the environment. Look at the laughs. That's good. The mercury levels in the studies that I'm doing with the mercury levels have to do with the natural mercury or the mercury levels we're seeing on the land. So for instance, right behind me here is Devon Island. And on the top of that ridge over about 100 kilometers is a lake that I studied 15 years ago. And in that lake, we found elevated levels of mercury down in the sediments. And those elevated levels of mercury down in the sediments matched the changing with the climate change. The other thing that was interesting about the levels of mercury in that lake just behind us here was that the amount of mercury in that lake was very, very high relative to what we thought the amount of mercury should be in the atmosphere coming in to the Arctic, which is where most of the mercury comes from. So most of the mercury is coming in through the atmosphere and gets into the soils, into the lakes. But the mercury levels are too high. So my colleagues and I came up with a theory, and the theory is called the scavenging theory, or the theory of biological scavenging. And this theory is basically trying to account for the fact that we don't know where the extra mercury is. And our theory basically says that it's the biology, it's the small microscopic organisms that are collecting this mercury and bringing it into the lake and concentrating it so that we're finding it. And therefore, that concentrated level of mercury is why we're not able to match the amount of mercury that's coming in from the atmosphere where most of the mercury comes from. So that's one study that I've been doing. And that study is very controversial because a lot of other people say that it's only mercury from the atmosphere that's the problem, not this accumulation on land. So right now in the science, we're on two sides. We're both sides trying to figure out what the real answer is or what the right answer is. But right now, we can say there's too much mercury in the lake, and so that's really the final solution for that. My second study that I want to talk about briefly is with arsenic. And in Yellowknife, which is in the Northwest Territories that way, there is a mine that was active for about 60, 70 years, and it was a gold mine. And the gold mine was actually digging an area where there was high levels of arsenic in the ground. And so as a result of what we call a byproduct of all the mining activity, massive amount of arsenic freed up and put into the environment. And right now, today, we have a problem. We don't know what to do with all that arsenic. And at the present time, most of that arsenic has actually been put down underground back into the old mine. And the question now that we're facing is how do we clean that up? In the case of my research, what I'm interested in knowing is, and remember I talked about the fact that arsenic is there naturally. So my question is, what were the levels of arsenic in the lake 200 years ago before the mine was actually active? Into the lakes, we're going to be coring the bottom of the lake. The amount of arsenic happened. Idea of where the mine is put into the lake systems around the area, that is, and in the past it's driven levels of high arsenic in the waters. So that's the second study I'm working on. Both of those relate to contaminants in the Arctic, and both of them are relevant to the kinds of things we're looking at. And I'll just finally end up by saying that climate change, which is another factor that comes into play here, because as the climate warms up, the chemical reactions warm up, and believe it or not, that actually may help to reduce the amount of contamination in the Arctic, because the breakdown of the chemicals will be faster. And in the case of the organic contaminants that we make, those will break down the organic contaminants faster. But in the case of the metals, which is what the research that I'm working on, those won't break down, they'll always be there. So there'll be a differential problem with contaminants in the Arctic in the future, and we have to identify what those are. But right now, I would probably say that one of the things that we can we can do a good job monitoring our metals. We can enter plastics. The organic contaminants, the things in the chemical herbicides and pesticides, those are things that could be more problematic, and they will be strictly related to the local communities. So I've given you a ton of information, way too much, but I think maybe at this point you might want to, if you have any questions, give us some questions, and otherwise I'll just give you a little bit around the bow of the ship. So have you got any questions?
Do we have any? No? We told you everything?
Okay, so before we just do a quick, before we do any kind of a walk around, how about I ask you a question, and the question is, if you were to try and studies a contamination in the Arctic, what would you do? Nothing. I heard somebody say nothing. Why would you do nothing?
Because they don't want to go there.
Too cold.
Yeah, too cold.
Okay. It's too cold to come here, so you don't want to come here and to study because it's too cold. So what happens if the fish you start to eat, you need to eat, are coming from the Arctic and they're contaminated? Then what are you going to do?
I don't know. Eat fish.
Don't eat fish. Well, that's a solution. Don't eat fish. You become a vegetarian. That's not so
cold. There
bad.
are people swimming today.
Actually, we just said people were just swimming here today, so it's not that bad. So I think you could survive.
Hey, Paul, we have a question about the tools and the equipment that you're using to carry on your research. Can you show some of what you're using?
Yeah, sort of. We can flip around here.
It's the crane.
So that is the crane. Oops, I can't see it myself there. It goes over the side of the ship. How about we move closer to the side?
We can see it. That's good.
And so that crane, can you see anything? There we go. So that crane is going overboard. And with that crane, we're putting the nets, and then a wire mesh off the crane is coming down, and then we're putting the nets that were, yesterday, for instance, we put a net down 100 meters, and then we brought it up at 1 meter per, basically per second. And with that, we got all kinds of interesting stuff. And unfortunately, because of the internet problem today, I can't show you this stuff, but because I can't show you the microscope. But anyways, it was pretty spectacular, the kinds of things we pulled up. And in all cases, everything indicated that the water was in pretty good shape. A lot of diversity, the kinds of things we would expect to find here, the kinds of algae, and also basically the small invertebrates that I saw in the microscope. Those are all things that are naturally here, and the numbers were good. So, again, contaminants, there's not a major issue with this time. There's local problems, but it's something that we need to really work on in the future. Oh,
There's a crane coming up right there. If you want to show
oh,
them.
okay. There we go.
That's similar to the crane that you guys use, right?
Yeah.
We can walk down there.
So actually, if you want to see, we're just in the process of putting a Zodiac in the water. Can you see that?
Yeah, yes, we can. We love it. Show us.
So if you just want to wait a second, you'll see them pick up a Zodiac and put it in the water. Wow. Okay, so right here are there's 1, 2, 3, there's 4 Zodiacs here. And if you also look carefully, there's a kayak as well. So those are the boats that we're using. The Zodiacs are the main boat that we use to get to and from the land. Saw a picture of the land already. And here we come. You're going to see now the crane. Yeah, sure. Oh. Yeah. I got it.
Whoa.
I got it. There we go.
Okay. You want to walk up and check that?
Perfect.
Yeah, I'll go this way. Oh, yeah. Okay, cool. Go ahead.
Okay. So while we're waiting, we'll take you through the lab. So this is the chemistry lab right now. See here, we have a whole rack of filtering. We have a vacuum pump system. And what we're doing for this is we're looking at water quality. And so the water chemistry, we're looking at the nutrients in the water. We're looking at the metals in the water. So the kinds of water analysis we do are filtered through here. We take the filters and then we freeze them. And we freeze them in a standard freezer, which is sitting here. And that's running it at minus 20 degrees C. And for the environmental, how are we doing for way? We're running a freezer right here at minus 80 degrees C. So we have the two different levels of temperature, and we're saving different samples. And general processing is right here. I can show you a few scopes. There, okay, there we go. Yep, or that.
That's a whale. Ask him if that's a whale.
That's a whale. Good. What about that?
Arctic wolf.
Carnivore because of the teeth. Yes, that's right. And the size, based on the size.
Wolverine?
Yeah, it's a young polar bear.
I was.
Okay.
Lichen? Yeah. Lichen?
Yeah, good. That's a good one.
Ask him what it is.
Some kind of egg sac?
Yeah, okay. How about this fossil?
Orthocone.
Orthocone.
Yeah, good. We're running out of things to show.
No, these are neat. Take it all. You want to take some questions from Science Alive?
Want to go into the lab?
Yeah, sure. Yeah. So let me just check something. I was hoping I could show you a water sample, but unfortunately the microscope's not working up today. But there we go, good hairdo. But I was just wondering, do you have any other questions, or is there any other things that are of interest? Oh, I can say one thing that was interest to me was when I came up here, my suitcase didn't make it. So what you see here, the clothing, I had to borrow some clothing, and I only have one pair of pants. So it's been sort of an interesting time, and you can see that I don't have anything to do any other activities with. So it's been rather interesting to survive with with a limited amount of clothing. Let's put it that way. But I did get lucky for boots, having to go into the water and get very cold at minus 2 degrees C.
Do you have all your gear now?
Are you fungi?
I couldn't hear the question. Yes?
How fast does fungi grow?
How fast does fungi grow?
Fungi?
Yeah.
Fungi.
Okay. Okay. The organisms that I study, the algae, and partly in the fungi, they grow quite quickly. My algae will they will divide sometimes as much as once every day. Usually it's once every 2 days or once every 3 days. Yes?
What kind of fungi you found?
What's the biggest patch of fungi you found?
Okay. Let's see. So the biggest one that I've seen would be about that big. It was a lichen, so it was a fungus and an algae combined. So there was two things growing together in a symbiotic state. That would be the biggest ones that I found. I found a lot of small mushrooms. So that's a fungus, right? Small mushrooms, and they would have been about let's say that high. They're not edible, so you wouldn't want to eat them. What would you eat if you were in the Arctic? What would you eat?
Instant noodles. Instant noodles.
Yeah. Well, of course, remember the people in the north, they primarily go for fish, right? Or they go for mammals. But if you had to eat plants, if you're really desperate and you had to eat plants, you could eat what's a plant called sorrel. So it's a green leaf that you can eat, and that will help you to survive. Some people have known to eat lichens and fungus, what you just talked about, a lichen. Good, and their nutrition's not that good, but that will help a little bit.
Can we eat algae?
And some of the seaweed would actually be very good. Any other questions? Yep.
What other plants grow in the north?
Okay, there's many kinds of plants growing in the north. For instance, here's one. There's a tree that grows in the north. Any idea what it is? It's called a willow tree, or the salix. Now, how big do you think this tree is?
Pretty big.
Take a guess.
Small. Couple meters tall.
I like small. I like the answer small. Usually they're about that big, and they grow that high.
No, that's not fair.
So it's not really a tree. There is one tree. There is one place here where the tree can be as tall as I am. Place that I know of, and that is on the far west side of the islands of Victoria Island. And I've been there to see these trees, but they're not very tall. About my height. Yeah, another question. Go ahead.
Are you a fun guy?
Are you a fun
Sorry,
guy?
can you repeat that?
Are you a fun guy?
Am I a fun guy? Good question. Okay, so if I study algae and fungi, am I a fun guy? I'm going to say yes. How's that?
Thank you so much, Paul.
Yep.
That was really interesting. Oh, more questions?
Hello. Hello.
Go ahead.
Hello.
Thanks again, Paul.
Thank you, Paul.
Go ahead.
Hello. How many kinds frozen screen? How many fungi did you have studied? How many different kinds have you studied?
How many different kinds of fungi have you studied?
No!
coming. Yes. Technology can definitely be challenging.